So other competitors have to rely on what's called error correction codes. So they're implementing the error correction through software integration, whereas we can do it at the hardware level. So they are way less resource intensive than IBM, Google, and others. And to give you a concrete example, we are working right now on building a first logical qubit, so an error-corrected qubit. And this demonstration for Google took 105 physical qubits, whereas for us, it will need only 12.
欢迎收看《投资聊一下》，我是吴彩妮。今天继续要跟大家谈谈的还是量子电脑。在量子电脑的运算当中呢，量子位元的数量是非常重要的，因为一个逻辑量子位元，它可能是由成千上万个物理量子位元通过量子纠错组成的，所以量子位元的数量要够多，要不然这个纠错率要非常的好，量子电脑才可以有效的运作。那今天我们要为您访问到的是法国量子电脑公司 Alice&Bob 的美国总经理，请他来告诉大家为什么 Alice&Bob 可以用很少的量子位元就可以做出可靠的量子电脑。Hello, Miss Juliette Peyronnet. Welcome to our show. Thanks for joining us today.
Thank you very much for having me. It's a pleasure to be here.
Good. So we're excited to have you here to share your insights. Let's talk about Cat Qubit. Many in our audience may not be familiar with quantum computing. So could you please explain what Cat Qubit technology is?
So yeah, we've been developing Cat Qubits for the past 5 years. It's a type of superconducting qubit, so very similar to the same platform that Google and IBM have. It's just the design on the chip that is different. Instead of using transmon, we use our own design, which provide great advantage in scaling up the technology. We are also able to use less supporting infrastructure and a physical footprint. We have a smaller physical footprint because of these advantages.
Oh, so why Alice&Bob choose Cat Qubit as your core technology?
So at first, the history comes from our co-founders that were researching this technology when they were doing their studies. And eventually, they were able to de-risk it and do a first demonstration of a Cat Qubit. Then there was like other groups throughout the world that were able to also kind of take the technology from the lab to the real world. We decided to really continue and invest in this technology, and we had the support from the French government to do so. And in the end, what we really saw into the Cat Qubit technology is that the path to utility was way easier to scale, more realistic for scaling than with other superconducting technologies.
So in terms of cost, is it much lower than your competitors?
So overall, when we will package a full system, yes, it will be more resource efficient because we need less chip and supporting technology in order to reach the same performance level. So overall, yes, at the beginning, we're still doing some core demonstration to bring this technology to the market, and we are making massive investments in order to de-risk it.
Yeah, got it. So Alice&Bob address error correction at hardware level. It helps to reduce reliance on large-scale error correction systems, right? So is this approach greatly different from other companies, other competitors?
Yeah, definitely. So other competitors have to rely on what's called error correction codes. So they're implementing the error correction through software integration, whereas we can do it at the hardware level and combine hardware correction and also the having on top of it the software layer. How it works is that there are two types of errors that are present in quantum computer, and we have one that is suppressed by design with our Cat Qubits. And when we implement our error correction code, then we can suppress one dimension compared to our competitors. So they are way less resource intensive than IBM, Google, and others. And to give you a concrete example, we are working right now on building a first logical qubit, so an error-corrected qubit. And this demonstration for Google took 105 physical qubits, whereas for us, it will need only 12. So we reduced by an order of magnitude the number of physical resources needed for demonstrating a logical qubit.
Understood. So for this quite new technology, what are the biggest bottlenecks and challenges that you ever face in your technology roadmap?
Yeah, so it's a technology that is pursued by very few players throughout the world. There's Amazon, ourselves, and a few other smaller groups. So there's not a lot of scientific result that we can build on apart from the work that we've done. There are, though, a lot of untapped potential because of that, but it requires a lot of resource and time in order to de-risk some of the key aspect of the technology that was already de-risked by other superconducting platform. At the moment, what we are trying to do is that we are building not only the qubit itself, but all the gates that are required for implementing an algorithm. And we need to be able to have a universal gate set so that a user can implement the entire set of application that they would be interested in.
So what key technical and commercial milestones must Alice&Bob achieve in order to deliver your quantum computers to your customers?
So in terms of technical milestone, at the moment we are working on this logical qubit on proving and demonstrating our logical gate set, and then we will have to scale the technology. And our objective is to demonstrate 100 logical qubits by 2030. And in the meantime, we will be de-risking these building blocks of like new gate set, improving the error correction scheme, developing application that require less resources. So that's where we are. In terms of commercial challenges that we're facing today, we're still compared to the entire community, a relatively small company. We have 150 employees, and we are competing against IBM, Google, Amazon, and so on that have way more resources and people in order to execute on their roadmap. So we have to be very smart in how we allocate our resources, and we are very lucky to have the support from the French government and our private investor, but we would have to fundraise again in order to support our roadmap in the future.
So is fundraising a really difficult job for you?
It comes with its challenge, and the European, I would say, ecosystem has been really supportive of the quantum computing ecosystem. So we are really lucky to have the support not only from France, but also from Europe. And as we extended in the US, we expect also to convince American investor for our next fundraising.
I think because people really think your new technology is convincing, right?
Yeah, no, definitely. And in the US, we already have the support from DARPA, which is a branch of the Department of Defense through their Quantum Benchmarking Initiative program. And we really want to leverage this to continue and build upon this great achievement for entering the US market.
Cool. So what will be the ultimate application of quantum computers do you expect? So what do you expect to be your first wave of users?
Yeah, in terms of application, we hear a lot about the potential in the chemical space for material simulation, for simulating protein, for pharmaceutical industry, or also for logistic or financial use cases and so on. There will be different stages in which these applications will be unlocked by a quantum computer. And the first ones that we've identified are really in the material science domain. So simulating small-scale material that are out of reach of classical simulation methods. And in terms of users, basically we are going after the same community that's using those high-performance computing resources in order to solve similar problem, but that face limitation in what classical solution can do. So the way it works is that those entity called like HPC, so High Performance Computing Center, they are usually funded either by the state in which they are located, and sometimes there's also like private investment into it. So those people will be, in this community, will be the first adopter in the technology, and we expect their user to be interested in running workflows application on a quantum computer. And there will also be an integration within the classical workflow that will allow an end user to run hybrid application using quantum computers, classical resources, and we see it already with other technology, with the arrival of GPUs for AI, for example, like the need to build bridges between different computing resources has already been developed and will have to happen for quantum.
Sure. So when the potential customers come to you, so what is the biggest challenges they need your help?
So the way you control a quantum computer and the way you implement application is fairly different from your day-to-day application using a CPU or a classical computer. So you need to learn basically how to encode your problem into a quantum algorithm. And for that, it requires a new set of skill, a new understanding of the machine in order to take advantage of it. So it's not only at the application level that works need to be done, but at the moment, a person that wants to leverage quantum computing solution needs to have a basic understanding of how the machine works.
True. So Alice&Bob has been growing rapidly, and the technical team is continuously expanding. How do you gain a competitive advantage in the race of talent acquisition, which is really important for your company, right?
Yeah, it's really hard. There's a scarcity of talent, and at the same time, everyone is hiring and growing. We've had like a huge expansion of the quantum computing industry in the last few years, and it will continue as in the same trend in the next few years. So the way we try to differentiate ourselves is by providing an environment that really facilitates collaboration with the academic world, because a lot of talents are coming from this place and really want to continue to work as researchers that are publishing paper, that are working with their peers and so on. So really encouraging collaboration with the academic world, but also the private sector, and allowing them to thrive as researchers within our company.
So looking ahead to the next decade, what is your vision for Alice&Bob in the quantum computing landscape?
So we are a leader in the Cat Qubit technology, and will continue to be in the next few years. We really want to position ourselves as a chip provider, working with integrators, like similarly to what had happened in the HPC community, where we would give a chip to an integrator that will then package it and install it in an HPC center. And we see that there's a need to build a relationship with local integrators, both in the US, in the APAC market, in Europe as well, and to continue to grow the ecosystem building around it, because it takes a lot of people to put together these really complex machine, and we're not going to be able to do it alone. So growing the ecosystem around like the implementation and usage of quantum computer is really critical for that.
So is there any partnership or resources that you are looking for in Taiwan?
Yeah, for sure. So at the moment, we are still kind of like we still remain in control of most of the development, but in the future, we really aim to partner with fabrication facilities, packaging companies that could like put together the entire system, or using local technologies, for example, for the control electronic of our chip. And we're really looking into like building this relationship in Taiwan and throughout the world. And Taiwan has a unique advantage of having a really strong semiconductor industry, and could position quantum into a priority to make sure quantum chips are fabricated in Taiwan, and also not only for the local market, but like for the global community.
So it sounds really inspiring. Thank you for sharing your perspective with us, and we hope you can visit Taiwan again soon and bring more exciting news with us.
Yeah, thank you very much for having me. It was a pleasure.
非常谢谢 Miss Peyronnet 今天来上我们节目。那么大家如果想要了解更多量子的相关话题，请锁定未来财经投资聊一下，按赞订阅，开启小铃铛。我们下次再会喽。
本节目感谢赞助播出。